Welcome back to another video. Here, we will talk about prediction confidence intervals. A prediction interval provides a range within which a future individual observation is expected to fall based on existing data and a specified confidence level. Unlike confidence intervals, which estimate population parameters, for example the mean, prediction intervals account for both population variability and the added uncertainty of predicting a single observation. They are important in practical applications, such as forecasting and quality control, where understanding the likely range of individual outcomes is critical for decision-making. Suppose we have a random sample of size n, x1, x2, up to xn, and instead of being interested in studying the population mean, we want to predict what would be our next observation. We can argue that x bar is a good guess, and as a result, our error would be the difference between the next observation and the current sample mean. The good news is that the expectation of our error is 0. But we need to study the variance of error as well, as not only we need to be accurate but also precise. Here we can see that unfortunately, we are not as lucky in the variance department due to the linear properties of variance. The variance of error would be variance of a typical observation plus the variance of sample mean, which is sigma squared plus sigma squared over the current sample size. Now, we can use the information about the error to define a prediction interval about the next potential observation. We can define a t-statistic that follows a t-distribution with n-1 degrees of freedom. Similar to the t-confidence interval, we can claim that the probability of t-statistic being between negative and positive t-values of t of 1 minus alpha over 2 with n-1 degrees of freedom is 1 minus alpha. As we are interested in constructing a prediction interval around the next observation, we multiply all sides with south times square root of 1 plus 1 over n and add sample mean to all sides. These steps help us to build a two-sided prediction interval around the next observation starting from x bar minus t of 1 minus alpha over 2 with n-1 degrees of freedom times s times square root of 1 plus 1 over n to x bar plus t of 1 minus alpha over 2 with n-1 degrees of freedom times s times square root of 1 plus 1 over n. It is important to note that prediction intervals are always wider than their corresponding confidence intervals. Intuitively, confidence intervals estimate the population mean based on an existing sample, while prediction intervals account for the added uncertainty of predicting a new observation. Statistically, the variance of the estimator used in a prediction interval is larger than that used in a confidence interval, resulting in a wider range. Thank you for listening to this short lecture on prediction intervals.